And we are in 3.2, conditional probability. Is that that's true, right? Yeah, okay. I was just making sure. So I thought that we had done some of this already, but maybe not. It all kind of blurs together for me. So I want y'all to remind me, what do we have for the formula for probability? I had said it a couple times. It's super easy. You have it in the notes. You don't? That would be the OR formula, yes. I'm looking for just like the most basic one, like the very first one I ever gave you. There it is. Selected over total. Oh, yeah, that one. It's like not complicated, at all. But yours was correct. It was just a different one. Yeah. Hello. And hello. I'm glad y'all are here. Peanut butter? Well, we had pizza earlier. Does that count? So selected over total. So this has not changed. What's going to, I guess, more is this. We're going to have the word given. That key word is telling us that there's something that's already happened. Now, what's the new probability? And I think that's just going to be more of the selected over total, but we just have to think this way, okay? Here's an idea. So let's say I have, what's the probability of me getting to work on time? Okay, so that's like, just let's go 90% because I'm super, I don't want to be late. But then what's the probability of me being on time given that I woke up late? A little different now, isn't it? See what I'm saying? So that given is saying something's already happened. Now let's go back and find the probability. Okay? That's all it is. Now, what does that actually mean? Well, let's go through it and we'll figure it out. So, 2 cards are selected from a 52 card playing deck. Y'all been playing cards since, last time, right? No, yeah. Okay. Find the probability that the first card is a diamond. So, how many diamonds are in a deck? Y'all don't remember? I could scroll. How about this? I'll scroll back up. You already got the total, yeah, but how many diamonds? Okay, hold up. We're going back. We're going back. 1/4. Okay, you already got the answer. That was great. 13. Yep, 13 diamonds. Or 1/4 is going to be the answer, right, in the end. So yeah. All right, now I got to scroll the way back down. Scroll, 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 scroll. So if y'all don't have the cards down in the brain really well, then you can just flip back to that page. So yeah, I mean, it's 13 over 52, or basically 1/4 is like one suit out of 4 suits, right? Selected over total. Okay, so far so good, right? Plain, basic, normal math. But then it says, find the probability that the second card is a diamond, given that the first card was a diamond. So, okay, I had one card, pick a card, any card, right? And then you pick a card and it was a diamond, 1/4, right? So you set it down. Set it down. Did you see what I did? I set it down. And then it says, now pick a card, any card. Find the probability that the second card's a diamond, given that you already picked a diamond and you set it down. There it is. There it is right there. You got it. You got it. 12 left over out of 51. Exactly right. 12 out of 51. Let me get some Desmos up on the side for the fraction action. Desmos. And let's see. All right. Let's check this thing out. So yeah, 12 out of 51, and it does reduce. Look at that. So just in case they want to reduce it down, that would be the way to do it. Okay, cool. Is that making sense? That I have to think about it like a brand new set. I already took one, I set it down. Now I only have 12 left. Okay, so good. Now find the probability that the first card is an ace. So the first card, brand new card, right? What is it? 4 out of 52. There's 4 aces out of 52. Let's reduce that down. I think it's like 1 out of 13 or something like that. Yep. Okay, cool. And then you set it down. Pick a card, any card, right? So find the probability that the second card is a red king, given that the first was an ace. So I already had the given. That already happened. So I want the probability of a red king. How many red kings are left in the deck right now? 2 red kings. We did not choose a red king already. What's my total? 51, exactly. I don't think that reduces. So I'm just going to, that's it. So did I do any new formulas? Not really. Am I doing any new math? Not really. It's just a new concept. Just new concept. Is that okay? Okay, cool. Any questions on that? All right, cool. Y'all are getting better at cards. Now you're going to start counting cards, right? No? You don't want to get beat up whenever you like win a whole bunch, you get beat up by the, toughs. Can I tell a small story about counting cards? Oh no. So for my undergraduate, I had a class called software engineering, and the whole keystone, I guess, program that we were doing as a group was to count cards. We were going to have the program count cards for us, and it was like 1 billion hands in like an hour, see how much money you make, that kind of thing. But in order to program how to make that work, I had to learn how to count cards myself. So you're going to take me to Vegas now, right? No, I haven't gone to Vegas. No one's paid for me yet. I'm a teacher. I don't make a lot of money. 21, or yeah, I think it's 21. Is that what it is? Yeah. Oh no, the one that I'm thinking of is like they made a team. It was like a math team, and they went to Vegas and did the counting. But they just counted just enough so they wouldn't know. You know what I mean? They wouldn't catch on. Okay, this still got beat up by the Tufts. Anyways, moving on. um, what you can do with math, right? Aha. So the following table is for researching IQ scores. Okay, so find the probability that a child does not have the gene. And that's it. Just simply, a child does not have the gene. So out of this table, how many people do not have the gene? 30. 30 don't have the gene. What's the total? 102. There it is. 30 out of 102. I'm sure that'll reduce. Let's check it out. Yeah. I mean, I don't know if they're wanting a fraction or decimals, but we could do whatever. So far, so good, right? So they say, what's the probability of not having gene given that the child has a normal IQ? So I'm going to use a different color now. Yeah, so given their only normal IQ, we're saying yeah, you got it right. We're looking like right here only, okay? Only right there. So high IQ, we're getting rid of that. And the total doesn't mean anything anymore, so I'm getting rid of that. It's like, in a way, that given is saying, rearrange the whole problem, and now I'm going to ask the same question. What's the probability of not having a gene? And so, like you said, 11 out of what now? Out of the 50. Yep, out of the 50. Exactly. Because I literally erase everything else because we don't need it anymore. This is the entire problem now. Cool? And so we have a total. It was the 50. There it is. Cool, right? So no new math, just kind of seeing what they're doing, I guess. Scrolling on. So we have all these different folks, I guess, and it says, what's the probability of randomly selected parent that is in the Army? And that's it. Just what's the probability of Army? What's the total amount of Army do we have here? 39 out of, there it is, 39 out of 96. Let's see if that reduces. I think they want decimals. They said decimals there. Let's do decimals. So basically 40%. Okay, I don't know how many, but that's good enough. Cool. But now, doing a different color here. But now, find the probability of someone in the Army given that we have female. So we're only looking at the females. Only these folks right here. That's all that exists. Males are not included. That total now is all messed up. That's no good. We don't want that. Okay, so now looking at what the new problem is, what's the probability of Army? 11 out of 24. Yep, 11 out of 24. So that's how we're changing it there. Oh, wait. I have to, there we go. I have to get the decimal. Cool. 4583. Good enough. Yeah, easy enough, right? Are you seeing that I'm scribbling right through it here? I think I mentioned this last time. Draw on your monitor. Like when you're taking a test in the lab, use a pencil and just you can erase it later. I just want to make sure that you like get rid of that entirely because it's not part of the problem anymore. Okay, cool. I advocate for drawing on monitors. Ooh, that didn't sound good. Let's do it again. Right. So what's the probability of selecting someone who's 50 years or older or more from among keyword given that we have male? So we need to select only the males. Okay, so no more females. That total's all messed up. So what's the probability of 50 or more? Yep, 29.4 out of. There it is. They're wanting decimals. So here we go. You can see how repetitious it is, right? But that's just part of the homework. It'll be very similar to this. And it's good enough. Cool. Yeah? Yeah? Is this cool? Any questions? Marbles. Okay, I'm gonna scroll. Here we go. So, oh, they want us to fill it in. Oh, this is definitely on the homework for sure. Yes. So basically, all of these empty boxes are boxes you're going to fill in with numbers. Yeah, that's perfect. Let's do that. I'm going to get a different color. Okay, so we have 155 employees and see if they're volunteering or not. Complete the table. That was it. Go. There it is. All right, we have a total here, right? Exactly right. So we could subtract them. So I'm going to do the 109 minus the 68. Calculator, of course, because I don't know that one. And we got 41. So 41 would be right here. Very good. I like that. Sweet. Is there something else we can do? Yep. Male volunteering. Yep. So male volunteering for 100. Here we go. No, just 30. I was thinking like Jeopardy, like 100, 200. Okay. We got the total 98. Subtract the 68 that we have there. 30. Yay. What's another one we can do? Female is the same style, right? So we're subtracting those two. 57 minus 41. 16. I'm trusting you. And then the total, how do we get the total volunteer? Yeah, we're going to add them up. Yep. These two guys, we're going to add 46. Yes, indeed. There we go. Cool. So we actually did have enough information to do that. Kind of odd how that works, but we could. This is exactly what's on your homework. I'm telling you, verbatim, copy paste. Cool. So, y'all have any questions about, like, I guess, how I'm strategizing? That's not strategy, Chad. That's tactics. No. Well, I hope not. I mean, this is Newton, so Oh, I was being recorded. I know, right? I can't get in my endorsement in there anymore. No, it should not be unsolvable. It should be solvable. That's a good question. Should be. So now that we got this, it says use this table to figure out the probability of employee does not volunteer. Okay, so not volunteer, given that they're male. So again, I'm going to draw all over it now. Let's do. Ooh, we got some pastel colors here. Let's do this nice bright color, so you can't see it at all. Totally unseeable. We'll just go with the wine color then. Okay, so given that they're male, we're only looking at the males. This is it. I'm sorry, I'm going to do this now. Okay, so we're only looking at that. What's the probability of not volunteering? 68 are not volunteering, total of 98. There we go. Very good, very good. Decimals, 0.69, says 2 decimals, so there you go. 69%. Sweet. Good. Okay, cool. Awesome, awesome. All right, what else do we got? Oh. Find the probability that the employee is not male given that they volunteer. It's different. It's differently worded. So I have to say that given that they volunteer. Okay, so hold on. Let's do that. So given they volunteer, this is the only ones I'm looking at now. It's like I have to erase it a little bit now. Yeah, that'll be fine. Draw. Okay, cool. So now they're saying, what's the probability of not male? What do they mean here in this case? Female, yeah. I don't know why they're doing that. And so, yeah, female would be the 16 out of, there it is. There it is. This problem was differently worded in past workbooks, and it was even more confusing. They had the not without like the comma in there or something, and it just made it feel like it was not blah 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 whatever else you do. So like it would have been 1 minus or something. But yeah, ignore all that. They just mean female. Very weird, I know. Just what it is. Okay, cool. Hooray. Math, it's so fun. And we're done with that section already? Let's go home. Peace out. No, I'm playing. Whoa. No, we got more to do here. It's continued. Look, it's continued officially. So independent. Let's remind ourselves about oh no, we talked about mutually exclusive last time. So this is different. So mutually exclusive. I'm gonna redo this because we'll probably see it again. Mutually exclusive means that it cannot occur at the same time. Cannot occur at the same time. But independent is a little different. Independent means that the two events don't affect one another. They don't affect one another. Okay, so let me give you some examples of independent. Okay, ding ding. I'm gonna let it go. So, anyways, independent. I am driving to work on time today. That was like 5:30 in the morning. What? Yeah, I woke up at like 4. So I'm driving to work on time. And another event on the coast of Africa, a butterfly flaps its wings. Totally not gonna. They don't talk. There's nothing related, right? Okay, I got another one. Ding dong. Okay, I got a ding dong on my phone just now. Okay, cool. So far, so good. There's a bird outside that just hit the window. I'm not getting ding dongs because of birds, right? Does it make sense? Nothing to do with one another. They don't affect one another. Are y'all understanding what I'm trying to say? It's not that they can't occur at the same time. Ding dong and a bird hit his beak on the window. Whatever, doesn't matter. But they're not even related. That's independent. They're not even related to one another. Okay. So let's go through this kind of list here. I know that it's all fancy words, but we're just going to go through this list here, okay? So we're wanting to see if it's independent or not independent, which is dependent. So list example of 2 events that are independent, 2 things that have nothing to do with one another, okay? And y'all are going to help me. A father has hazel eyes and a daughter has hazel eyes. Totally not related at all. Oh, they are related? No, they're not? Wait, what? Genetics, right? I have no clue what genetics. So I'm going to put a big question mark because I have no idea. I'm a math guy. Putting money in a parking meter and then not putting money in a parking meter and then getting a ticket. Can those like be related somehow? Probably. So are they independent? No, those are dependent. Rolling a dice twice. I take a dice and I roll it and I get a 5. And I pick it up and roll it again and I get a 3. Do those have anything to do with one another? Totally separate, right? I like that one. Totally separate. And then selecting a queen from a standard deck, not replacing it, and then selecting a queen from the deck. If you're not replacing it, then doesn't it change? Right? You had 4 queens. You take one out, set it down. How many got left? 3. Now all of a sudden it's different, isn't it? So see how they're changing one another a little bit? So I don't like that one. Are y'all going to help me with the Hazel eyes? Is this independent or dependent? Dependent? Okay, cool. I don't know. I figure though. List an example of 2 things that are dependent, so they do affect one another. Rolling a dice twice. No, we just said that it was independent. Tossing a coin, getting a heads, and then rolling a 6-sided dice. No, those are totally different, right? Drawing a card, not replacing it, and then selecting a different card. Yeah, that would change things, wouldn't it? Those would change things. Selecting a ball 1 through 12, putting it back, and then getting another ball. Yeah, well, if you put it back, it's going to be the same. So, is that okay? Y'all did number 2 pencil though, right? I mean, you got to make sure you fill them in perfectly. Scantron. Oh, okay. Any questions on independent? All right. I gotta have like y'all do some work here. A single die is rolled twice. You know what? I have a good idea. I'm gonna do it. I'm gonna have y'all do this one now on your own for just a whole second. Finally, there's like gonna be one moment where we can ever do this in this class. Do it now. Oh wait. Look, someone gave me a potato. I know. I'm gonna call him Spuddy because he's like my buddy. Anyways, I'm gonna hang out with Spuddy. Okay, y'all are gonna do that problem. I'm gonna wait. I know you got this. You don't have to have that formula. You could totally do this on your own. It's okay, Spuddy. It's okay. I actually call my cat Spuddy. Isn't that weird? Or Tanya. But he's a guy, so it's kind of weird too. Okay, Spuddy, hang out there. Cool. He's my new mascot. Until he rots. They do. I know this. So in my algebra classes, I'm doing this brand new thing. It's called I do, you do, we do. And it's a new thing. And I don't get a lot of opportunities for y'all to do it. Normally it's just me going blah, blah, blah. You already got the answer, I'm guessing? What's the answer? Just give me the answer. You. Chad, you didn't explain it. Yes. Okay, then I'll wait a minute. Yes, good assumption. 6-sided dice, yes. That's actually a good question, though. Because they were asked about 12-sided dice the other day. You got the answer? I know you do. Here we go. Give me the answer. 3 out of 6, which goes down to 1/2. Did y'all get 1/2? Everyone got 1/2? Then let's do it. I'm going to do it. So it's like I do, you do, we do. So now it's the we part. Thank you. That was excellent. So a single dice is rolled twice. Find the probability of rolling an odd number the first time and then another number greater than 2 or whatever. So, okay, the first roll has a 1, 2, 3, 4, 5, 6. Second roll has a 1, 2, 3, 3, 4, 5, 6. And so it says odd number the first time. Okay, so that's a 1/2, isn't it, right there? Half of them. And then it says the word and. So what does and mean? Do you remember? Multiply, yes. So and means to multiply. What does or mean? Add, very good. Okay, so and then it says the probability of greater than 2 on the second roll. So greater than 2, wouldn't that be 3, 4, 5, or 6? Okay, so that would be 2/3, I think. Okay, cool. And so then if I'm multiplying it straight across, and you can use a calculator with this one, I think it's going to be actually 1/3. So let's see. So I got 1/2 and times 2/3 and fraction action 1/3. It's okay. That's why it's a I do, you do, we do, right? I can't just leave it as it is. Does that make sense what I just did though? Yeah? Cool. Cool. But see, in a way, we do the you do so that you can see if you're on the right track or not. And it's okay to make mistakes. Did you know that one of the best ways to learn is to make mistakes? It sucks though, but it's like literally the best way ever. Cool? Okay. That was fun. Let's do another one. Y'all can do this one. Do you want to do this one now? You're like, no, bro, I don't want to do this one. 2 cards selected without replacing the first card from a standard. Okay, so like one card and then the next card. Find the probability that they are both hearts. So, okay, I want to do the first card and then I want to do the second card. And so we want hearts and hearts. What's the probability of a hearts from the, just pick a card, any card? 1/4, one out of one suit out of the 4 suits, right? 13 out of, let me write that up. I like that one better. 13 out of the 52. But then I take that heart and I set it down, right? Without replacing. How many hearts are left? 12 out of 51. And it just says, what's the probability of this happening, both of them? High. So and means multiply. Here we go. Calculator to the rescue. Because I don't know that stuff. Oh, okay, cool. 1 out of 17. Yay. Doo-doo-doo-doo. Is that okay? Oh, this is one of my favorite problems. I do like donuts, but I can't really eat them because they're too much sugar and stuff. But anyways, Elizabeth brought a box of donuts to share. Love it. And she got 2 dozen donuts. That's plenty for all of us, right? I'll have 8. Y'all have the rest. And they're all identical shape, size, and color. 2 are jelly filled, 5 are lemon filled, and 17 custard. Okay, I'm gonna tell you, I don't like custard. I just don't like it. I'm sorry. I know y'all like the custard. Y'all can have the custard. I want the lemon. I like lemon. So it says, what's the probability of me eating a custard filled, going ugh, and then I get my lemon fill. I'm like, oh yeah, this is the one I wanted, right? So what's the probability of that happening? And so I'm gonna eat 2 donuts. Here we go. I'm gonna make little donuts. Okay. There's my one donut. Here's my other donut. Now eat this one donut, and then the next one. What does and mean? Multiply. Those little circles in the middle are totally gonna annoy me, so I'm just gonna put the numbers instead. How many custard do we have? Out of 24. Okay, and then I got a lemon. How many lemons are left after I eat this one? 5 lemons are still left because I didn't eat a lemon. But how much total? 23. Very good. My total on the bottom has changed, but the lemons didn't change. Yes, very good, very good. And then you put a multiply between them, and there we go. I think I'm going to want the decimal. Awesome. 15% probability of me going, ugh, and then, ooh. Good. It's more of a human implication. And I got to say, on the top one here, the wording is really poor. So I'm just going to tell you that straight up. It says select 2 cards, and all of a sudden it's like pick a card, any card. I'm thinking that you're pulling 2 at once, which is not really their case because they're implying that we have a first and therefore a second card. And so let's think of it like take a card, any card. You take one, and then you take a second one. So far, so good. So then I took one, and then I took a second one. See the key word that it's implied here. It's not really written, but it's implied. Great question. So much implication. We have to know almost. Very good. Very good. Are y'all cool with that? Seeing the difference, right? Yeah. Humans. We have to always think about these things. The probability of a company has social media account is this much. Probability that it has a website, whoa, given that it has social media is this much. What's the probability of this and that? Okay, let's pause for a second. I think we're going to need a formula for this one because it's finally given to the point where there's an and, there's a given, and there's something else going on, and I don't really know what's going on here. So this is what I'm going to do. I'm going to go back up to the formula that we skipped right here, this guy. Okay. So what I want to do is rewrite this in CHAD language. I'm going to do, yeah, I know, because math is whatever, right? We got and is equal to the probability times the given, okay? So that little bar right here, that little vertical bar means given. And so this is kind of like the and, the given, and this is like the regular probability. I don't know what you want to call it, regular. Okay, so that's kind of like the CHAD version. And is equal to the probability of whatever you're looking for times whatever the given is, okay? So I'm going to use that formula. Is that okay? Here we go. I'm going to rewrite it down here. So and equals probability times the given. Okay, so and is equal to the probability of whatever times the given that they're going to give me. There we go. Okay, so let me fill in those numbers, right? So and. What's the answer for and? What's my number for and? Yeah, it's the one I don't know, right? So and is what I don't know. All right. So what's the plain probability? Like just regular. It's probably the 27, yeah. And then see how it says the given? The given is, well, sorry, this guy, 0.9, right? And so they want me to multiply them. Okay, I can do that. This is one of those moments where it's not so easy to just like, circle the right one, I guess. You have to almost have like a formula. So that's what we're doing. So the keyword given there, given that they have social media account, that's let's go in here. Do you want me to do it full longs? I'm gonna do it full wise. Here we go. Here we go. And we got plenty of room. So I'm gonna say the probability A and B is the probability of A times the probability of B given A, right? That's basically the real formula on the other page. And so I need to replace these with like real things. So let's do social media. Let's do S. And let's do the website will be a W. Yes? Okay, cool. And I'm looking for, first off, it says the probability of social media. So the probability of social media, and therefore this would have to be website given social media. So did we have, what's the probability of website given social media? So it says the probability of has a website given social media. See how it like lined out that way? So that number definitely would exist right here for this guy. No, it was a great question. See, and this is where CHAD formulas are kind of, but then like the actual formulas are they're just kind of more complex. Is this okay? That was a great question. I really like that. And then yeah, the social media they had already said was the 0.27, and so then I multiply them, and that's what we got right there. Cool. So either way, you can do the CHAD method, which is like, yeah. Well, I know you took me for this class, right? Why did you take me for this class? Because it was the only one. Okay, I'm sorry. Moving on. So find the probability that a child is unvaccinated visits the doctor's office this much. Okay, hold on. Keyword and. Keyword and. Okay. Probability visits doctor's office given is this much. So what's the probability of this? You see the keywords there? So that's, again, this is why CHAD version, I like to do this. All right. What is my and probability? 0.3. What's my regular probability? It's, yeah, we don't know, right? We don't know. But what's the probability of the given? The 0.69, right? Exactly. So see how I'm kind of setting it up? Kind of like an equation almost, right? And then I need to solve for what I don't know. How would I get my unknown by itself? Divide. Yeah, divide. Yeah. Chad, are you asking me to do algebra in a stats class? I did not sign up for that, Chad. I know, I'm so sorry. It's okay. We divided on both sides. That was the extent of our algebra today, okay? I don't know what I just did. Stop. No. Draw. Okay, we're good. Okay. 0.3, 0.69. There we go. So 0.43478. Cool. There we go. Good times? Any questions? I'm here for you. Does this get boring sometimes? No? Yes? Okay. Is it easy math, though? That's why? Okay. I know. It'll get not harder throughout the class. Okay, I can promise that chapter 9 is actually pretty difficult, okay? But besides that, it honestly does not go too deep, which is good, right? That means you can pass my class, and I want you to pass my class, okay? So this chunk right here is actually really cool. It's a summary of what we've already done. So it has all the little formulas, and it talks about the stuff here. Really neat stuff for note cards, right? Like for on tests and stuff, but I wouldn't say it's required. And now we move on. So this next section is mixed reviews. Okay, I got to say that the first part is really fun and exciting. It's really a cool section. The second part of it is not. Okay. Whenever we get to this permutation stuff, but then they get more complicated, I start to get upset. But you'll see on Thursday. So we're not doing that today. All right. So counting principles. Review fundamental counting principle. Really all they're trying to say here was that we were multiplying. Okay, so you need to create a password of 4 letters followed by 3 digits. All right, here we go. A, B, C, D, 1, 2, 3. Yay! That's my password. How many different passwords can you create if each character can't be repeated? Right? That was the A, B, C, D, 1, 2, 3, right? So I can't put A, 0, 0, 0. That's totally not allowed, apparently. You get me, though? So what is the probability of this happening? Not probability, I'm sorry. How many different ways? Are you stuck too? Here we go. Here we go. It's like the license plate problem. Do y'all remember that from last time? Yeah. We did this already. If I have to pick for this one right here, and it's got to be a letter, right? How many different options do I have? 26. But then I picked one of those letters. How many options now? And then? Perfect. Now, these are digits. Yeah? So then how many digits do we have? 10, and then what do I do with all of these numbers right here? Do I subtract? Oh, multiply. Do I subtract? No, that's actually a Texas, okay? That's a little mini Texas. Look at that awesome Texas that I just made. Gross. Anyways, you multiply. Everything's being multiplied. And this is definitely calculator worthy. Here we go. Yeah, it's going to be a lot. 26, 25, 24, 23, 10, 9, 8. There we go. I guess I can kind of scoot this in a bit. Yeah, we got 2, 5, 8, 3, 3, 6, 0, 0, 0. Okay, so that's the amount of different passwords we can have. So if you go and try to hack into someone's account, what's the probability of that happening? Yeah, exactly. Not very good. What if you have a computer run through all the different options? What's the probability of getting in? 100%. The computer will run through it real fast. So that's why we use special characters, right? Y'all know how to do special? Yeah. It's like you need a capital letter and a little letter and da da da, and then all of a sudden it gets like super complex. So that's what they're trying to do. Keep the computers from doing it. There are 12 people in. Oh, I love this problem. There are 12 people in checkout line. The first person is being helped and will stay in the front. So here, hold on. We got someone here behind the counter, like, "Thank you for coming and shopping," and they're like, "Yay! I found everything I wanted." Okay, so we got that, and then we got people standing in line. Okay, and they're gonna just become more stick figure like because I can't draw. There, you get arms. We got 4, 5 right there, 6, 7, 8. 9, and then a 10th person. I'll give you arms and legs too. Okay. So it says the person in the back is chatting with someone else who is not in line. So he's going to stay in the back. They're like, "Oh, hi, friend." And he's like, "Yeah, da, 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 da." Okay, cool. Do you like my artwork or what? Right? Man, that's great. He even has so they're all going to get arms right quick. Okay, everyone gets arms, everyone gets arms, everyone gets legs, everyone gets legs, everyone gets legs. Okay, everyone got legs. All right. So what's the problem? How many ways can you rearrange the other shoppers? So like this is the section that we're talking about right here. These people are the ones that are in line for sure, not being helped, not talking to somebody else. You get me? And we're supposed to rearrange them. Someone's gonna get beat up. Could you imagine you're in Walmart and they're like, "Okay, I'm sorry, we're having a technical problem. Can you 8 people just rearrange yourself?" No. So I'm just gonna give them labels right quick: A, B, C, D, E, F, G, H. Okay, and so they're saying we're gonna rearrange you. It's gonna be C, A, G, H, B, C again, D, Q, and F. And there you go. You're like, there's not even a Q. My point is, like, you're rearranging them. You get me? How many different ways can that happen? I did not draw enough. My bad. So I did not draw enough. I counted too wrong. Hold on. Hey, I'm still important. And then we have a little kid down over here. Okay. Sorry. I did not draw enough people. Let me give them labels too. So you're the imaginary Q there, and then you're Z. There you go. Sorry, totally messed up there, didn't I? Yeah, because there's like he's like number 1 and he's number 12, and yeah, so there's 10. I'm so sorry. Wow, I totally messed up, guys. I can't count to 12. Okay. So yeah, now I got 10 people. You get me? How many different ways can we reorder them without them getting mad? 0. Yeah, don't do it. But there's got to be some math behind it. So here, I have an idea. Let's take all these people onto the side. Okay, so they're all standing like in a big pile of people that are not happy now. Okay, and then I'm going to start putting one in at a time. Okay, so I want someone to take up this position. How many different people could fit in this one spot? How many different possibilities? 10, exactly. So we got 10 different people that can go right there and then stay there in that spot. Don't move. And now I go back to my pool of people again. And I say, now I need someone over here. How many people can go now? 9, because that one person's already out, right? So now it's 9. How many here then? 8, and then, yep, and all the way down. 5, 4, 3, 2, and then 1. Here we go. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. There you go. So 3, 6, 2, 8, 8, 0, 0. Did I mess it up? No, I didn't. That's good. So 3.5 million different ways to do this. Whoo! Then people in Walmart, they don't know what's coming. Okay. Are y'all understanding the math there? Once I drew enough people, that is. Can I show you a quicker way to do this one? This one's like super fun. It's 10 factorial. 10 factorial. And let me write that down, okay? Because it's coming up here. Well, it's right there. You already have it in your book. Oh, I feel so silly. Ignore this permutation for a second. This guy right here, that's n factorial. And so here in my case, this was 10 factorial. And I know you want to just say, it's 10! No? Okay. Small story. Oh, man, not another story. We had a Professor Lyles was becoming one of the other professors that was working with us. He's now a dean, by the way. Whoa, I know. And when he was teaching us, the teachers, right? That's kind of like a promo thing. He was like teaching us permutations. He's like, "Oh, look, it's 4." And I was like, "You're hired." He's a really awesome teacher. Anyways, so yeah, it's not 10. It's not 10. It's just 10 factorial. And what it does is multiplying all the numbers down to 1. That's all it is. So if I had 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1, and then you get the number. Does that make sense? You just start with that number and go down? Cool. Easy enough, right? They got a little caveat. They say that 0 factorial is 1. And I'm going to say, Desmos, prove it. And yeah, it's already been programmed to do that. It is kind of a weird thing, but if you ever get a 0, it's just a 1. And there you go. All right, good so far? Now we're going to use it. 6 National League Central Division teams. So there's 6 teams. Okay, so how many different final standings are possible? I have no clue what's going on with this problem. Okay, are you going to help me with this one? I must live under a rock. So, like, we got 6 teams, and they're saying standings? Is that like how they end up in the end? Who's winner, who's loser? Okay. No, shrug. You think? Oh, okay. Well, we're going to go with that. So we got team A, team B, team C, team D, team E, team F. That's 6. 6. Okay. And so then they're wanting the different ways. So this is one way. Couldn't I do B, A, C, D, E, F, right? Couldn't I do A, B, C, D, F, E? Couldn't I do A, B, F, E, C, D? Like, how many different ways can this go? Oh, you already did it? Okay, so right, it's 6 factorial essentially, right? It's 6 times 5 times 4 times 3 to 2. It's the same thing we just did up there with these shoppers, right? Here we go, 6 factorial. Yep, you're right. Look at that. So 720 is the answer. Yay! Yay! I know, right? All right, cool. Is this good so far? Now, why do they call it permutation? Why do they have this permutation word here? I honestly, I don't really know. I don't like it. I think what we're doing here makes more sense with permutation. So this is where things are going to, change. This is like a hard break here. Here we go. It's going to make fun. It's the fun zone. Here we go. So permutations, okay? And then if you keep scrolling or you flip, then we have combinations. Okay, so they are very similar. Let's talk about the difference, okay? So permutation is when order is important. When order is important, okay? So when order is important. And then combination is when order is not important. So there's your difference. Order is not important. So order is important, order is not important. Cool? There's the difference between the two. What does it mean for order to be important? This is a human thing. This is an interpretation thing. Are you ready? I'm driving a race car and other people racing with me, and I want to be first. Is order important? Heck yeah, it is. Okay, cool. Here's another one. We're all standing in line to get an experimental drug, right? They're going to start giving us either placebos or like freak out pills, right? Is the order important? Everyone's going to get their pill. Oh yeah. Okay, here's another one. I've got some change in my pocket. Bam, change in my pocket. Is order important? Not really, unless I'm like super OCD and I want to make the quarters all first. You know what I mean? Okay, so let me think of another one. Order not important. Order important. That's all I got right now. Sorry. Making sense though? Like we're gonna see more real world situations. So let's go through. So when order is important, and then they'll say when order is not important, and then they'll have questions about tell me which one it is. And I think we might stop there. Yeah, I don't want to keep this is crazy stuff right there. Okay, so we might be stopping at that point. We'll see. So we're near the end already. It's okay. Board of Directors has a company of 12 members. One member wants to be the president. One wants to be the vice president. Another one be the secretary. Then another one's treasurer. How many different ways can these positions be assigned? I got to ask a question. Is order important? Yes? You think so? I think so too. Who's the most important here? The president. Who's second most important? Who's the third? Are you sure about that? I think the treasurer, though. He's got the money. I'm playing. I'm playing. You're right. There's an order to it, a ranking almost, right? And so order is important to these people. President wants to be president, wants to be first, exactly. So I've got 12 people who want to go onto this. And I'm using this P for permutation. See this little NPR thing up here? It's kind of like a notation thing. And this is going to be my total number. What I want to know now is the other number that might be used up here. What is my selected? How many people are being selected for positions? 4. And so that's the notation that they're going to want you to use. Okay? So that's what it's going to look like. 12P4 means order is important. That's the P. 12 is your total. 4 is being selected. Isn't that the same kind of thing like probability in a way? Now, to do this in Desmos or GeoGebra, I'm just going to use Desmos today. I think you have to use the NPR 12,4 in both of those systems. Let's just verify. So NPR, yep. And I think that GeoGebra also has this. If you want to use GeoGebra calculator, it's the same thing. You type it in like that, you get your answer, and you're done. Okay. I think there's a button for it too somewhere around here. Function? Oh, there it is. NPR NCR. So that's the questioning that we're going to do. I have 2 numbers. I ask, is order important? You say yes or no. And then we put the total in selected and we're done. And we're done. Did you have to use that formula? No. Are you ever going to have to use that formula? No. It's a good thing. Good? Here we go. All right. A website password must include at least, we just talked about this, 5 letters and 5 numbers. How many ways can you do the 5 letters from 26 if the letters must all be distinct? Like, you can't have repeats, right? I think they're only talking about letters here, right? Aren't they only saying letters, letters, letters? Like the numbers had, and 5 letters, right? So they're not actually saying anything about numbers here. I have a question. Is order important to you? Is order important? No, you don't think so? Let me show you about this. Oh, I'm going to put everyone's password up here. Oh, no. Oh, special character. So, isn't that what everyone's password is to get in their email? You don't use that, bro? Nah, you got that smile, though. Okay, I'm sorry for giving it away. But what if I were to type this password a little different? What if I did this? Would it let me in? No. So is the order of the letters important? Yes. So what I'm saying here is that we're saying order is important. Yes, we're going to start with a P. P stands for permutation. Order is important. What's my total? 26 is the total. Again, this is the bigger number. And then what's my selected? 5, exactly. 5 is my selected, my smaller number. And it's always going to go that way, bigger and smaller. Oh, here we go. And PR 26, comma 5. Here we go. 26, 5. And there we go. So there's this many passwords possible in this, or the letters possible in this particular format. Is what we're doing okay? The how? Is the why okay? You're like, well, the why is that you want to pass my class. And then we can move on. So now they're wanting to talk about combinations. Again, order's not important. And that's kind of what they're going to be doing here. I'm going to still ask, though. So a manager in a department wants a 3-man team for the 20 employees, blah, blah, blah. How many ways can you do it? This 3-person team is not, it's not like president, vice president, right? It's not saying anything like that. I'm going to ask, is order important? Order should not be important in this case. Also, it's kind of telling you it's a combination. So you're going to use C because order not important. Order not important. What's my total? 20. What's my selected? There it is. And CR, C stands for combination, stands for order not important. Put it in, and we're done. And that's it. So you don't have to use these crazy formulas. You just have a calculator that does it for you, which is so nice. Yay, calculator. I'm trying to make it exciting, guys. One time my algebra class was like so not talking, I jumped off a desk and hurt myself. But I mean, at least it was something to keep the conversation going. Did you want me to try that here? Thank you. You too? That's funny. Okay. Dental students in a university must choose 2 classes from natural sciences and 3 classes from dental school. Okay, well, if they say so. How many different combinations of natural science and dental classes can they take without repeating a class? What? What? I think the keyword is and. The keyword is and. And what does and mean? Multiply. I'm going to multiply thing over here and thing over there. I think they're going to talk like science and then the dental. Okay? So I think that's how it's supposed to work. Let's just talk science. Just science. Okay? So dental students in a university must take 2 science classes. And they have 13 science classes to offer. I'm going to ask, is order important in the end? Do you have to take English before history or history before English? No. And I know you're thinking, science, I get it. Anyways, not important. Order not important. What's my total science? And then what's I selected? 2. So 2 classes from those 13. As long as you got them, biology, chemistry, we're good. We're done. We move on. Okay, now for dental. So is order important for my dental classes? No clue, but let's just say no. You got your teeth cleaning one, and then you got your plaque building one. No, plaque cutting one. I have no clue. I know. You got your brushing class, and you have your flossing class, and then you have your power drill class. What's my total? Out of? And so I'm going to put both of these in at once. What it would look like on the calculator is my 13 NCR2, and then I'm going to do the 18 NCR3, and just put a multiply between them. NCR 18.3. There we go. So all the different variety of ways you can get these classes taken care of. I think that it's important because they're 2 separate events. There might be a way to mush them together, but I'm not going to be risky today. Good question. That's very good. The simple Chad method is that we got this one, and then we got this one, and then we just mush them together in the end. Good. Very good. And so notice that the whole thing came down to a keyword and. One little word like that. Got me? Watch out for that kind of stuff, okay? Oh yeah, okay. Last one, and then we got the fun stuff, and then we're actually after this little cool thing, we're like basically done. I don't want to keep going, okay? So we're almost there. So a bingo game has 11 white balls, 1 through 100, and we got red balls, 1 through 25. And so we get 5 whites and 5 reds. How many different combinations without repetition? So is the order important in which you're pulling out these balls for bingo? Is it bingo? They said bingo. I'm going to say no, just because I have no clue. But let's say order is not important. And we're going to talk about the white balls. And then we're going to talk about the red balls. How many total white balls? What's selected? Just the 5, right? And then I'm going to have how many red balls selected? Mush them together. And let's get the answer. Now this is going to be a pretty big number because I mean we got like 100 up there. This is probably how bingo halls or whatever you would call them make their money. They're like, no one's going to get bingo today. Whoa! You see that number? Oh my gosh. 4.0000025 times 10 to the 12th. It's like, is that there many atoms in the universe? I mean, that's so crazy. It's more than that with atoms, okay? I have no clue, but like someone's got that number, you know? Okay. That's a lot. We could play bingo forever and not get done with our bingo. Good? Is this okay? Then now, this is the last part, and it's so fun. This is my favorite part, really. It truly is. So, y'all get to help me pick if it's a combination or permutation, okay? The permutation, again, is order is important. Order is important, okay? The combination is order not important. And everything here is implied. You have to be like a normal human to be able to figure this thing out. So, I'm sorry. That's why y'all are helping me. The way 10 people can line up for movie tickets. Is order important for lining up for movie tickets? Yes, you say no. Hold on. I got it. So let's take a vote now. I love this. Who in here thinks it's super important to make a line for movie tickets? 1, 2. Who does not care about the line for movie tickets? Oh my gosh. Y'all win. But I gotta say, the math is that order is important. And I'll tell you why. It's a very simple thing. I want to be right up in the middle on the top side. That's my favorite place, right? But then if I came in first, you came in second, all of a sudden you're like, bro, you took my spot. And I'm like, nah, man. Order doesn't matter. No, someone's going to get beat up, right? You're okay. Yeah. You get what I'm trying to say? I'm going to say in this particular case, I know it's not voted for, I'm sorry, that order is important. Okay? What would be my total? 10. What is my selected? 10. 10 people were lined up, 10 people were watching a movie. Calculator. And that is okay. 10 comma 10. And there we go. So I am saying that order is important. I know that y'all don't believe it. I haven't been to the movies in forever, so I have no clue. But this is how it's supposed to be. That's how the homework's going to be. Yeah. It's okay. We're going to do this together. It makes it fun. A medical researcher needs 34 people to test the experimental drug. 97 have volunteered. How many different ways? So is order important? Universal no. Order not important. What's my total? What's my selected? Do you see how easy this part is? They literally only give you 2 numbers. You get nothing else to do about this, right? And if there's only 1 number, you just do it twice. Bam. Here we go. And CR 9734. Whoa. That's okay. So that's a whole bunch of different ways that you can experiment with these people. On the homework, I think that they're going to have a box, and then they'll have like 10, and then like a box, and they'll just say 2 decimal places or something like that. I think that's how it works. They're also not going to do this very often, hopefully. Well, I mean, yeah, it's kind of straightforward, I guess. Yeah. So, how many different 4-letter passwords can be formed without repetition? Passwords. Order important? Yeah, we just talked about that one. So, order is important. What's my total? It's 26 because of the letters. How many letters, though? 4. Very good. Interesting, isn't it? And PR, 26 letters, 4 of them I'm using. Very good. 358800. Bloop. There we go. I can think of a lot of 4-letter passwords. Work. No, that's not what you were thinking either. Cold. Okay. Baskin Robbins often offers 31 different flavors of ice cream. One of the items is a bowl consisting of 3 scoops. So there's my numbers there. Is order important? Yes. Okay, so you're going up with your bowl and you're like, okay, I want strawberry, and then I want chocolate, and I want vanilla. And they're like, nope, we're going to give you the chocolate first. You freak out. Is that really what's going on? I know, right? We're trying to think a little bit normal here. So right here, here's my key word. Is order important for a bowl? No. I'm going to say no in this particular case. Order not important for a bowl. Yes, I know. What's my total? Out of? Or 3 out of 31. Sorry, you're right. Now, I know what y'all are thinking. You hold on. I'm not done with this problem, okay? Y'all have good thoughts. That was the key word, was bowl. What if I replaced it with cone? Whole different ball game. No, I'm serious. Think about it. I want my strawberry, chocolate, and vanilla, right? And then you're like, no, man, I'm gonna put the chocolate on top. No, you will not. I want my vanilla first. Do you see the point though? So a bowl is like they're just all in the bowl, like 3 scoops, you're done. But like a cone is like stacked on top. That's the little tiny ones, but I mean, huh? Oh, do they do that with a bowl? How am I supposed to eat the bowl though? You eat the bowl with a spoon? Uh, do you eat the spoon when you're done? Anyways, I would say the cone would be just me personally, okay? Maybe I'm just a little bit OCD here, but I would use the P for cone. And you know what's interesting? What if I just change this to a P? And notice the difference in my two numbers for a second, right? Like this one had 4,000, now it's 26,000, right? Big difference. Big difference because order is important. It could be a lot of different ways. I just wanted to make that point. This is the last question of the day. Here we go. Patients in a trial are taking 5 medications. Researchers want to see whether the 3 specific medications reduce this and that. How many different ways? After whoa. Can the 3 medications after their other medicate? What? Okay. Yeah. Oh, I guess. Yeah, that makes sense. This is actually, I got to say, this is not in my workbook. This is a new problem. I have no clue. So, is order important? What do you think? No? So, hold on. I'm going to take the blood thinner, and then I'm going to take the caffeine pill. I'm taking 5 of these things? No, I'm playing. I'm sorry. Yeah. Oh, is that what's going on? Oh, okay. So, is order important? Oh, yeah, that's true. But then aren't I taking all 5 at once, right? Isn't that how you do it? Nobody takes one pill at a time. You just toss it all in, right? I have no clue. Let's just do 2 separate opinions. So permutation, combination, because I literally do not know the answer, and that's okay sometimes. I have it here. You're right. Let me turn. What page is this? 70, page 70. Here we go. I'm turning to page 70 right here. We're being recorded. Oh, my page 70 is not the same. Okay, let me turn like a page. Maybe it's somewhere else around here. And oh, here it is. I found it, and it's blank. Yeah, I've never seen this before. What would be the total here? What? Just give me a total. You like 8, and then it says specific what? What would we use? Probably the 3. Oh, okay. So that's what I'm gonna call it there. I have no clue. I have to go ask one of the other professors. Oh, you like that? So then let's go with that guy. Okay, cool. Mm. So, and I gotta say, on your homework, it's a little different than what I've been doing because the answer is literally just P or C and you move on. So you click it and you get it wrong, you click the other one, you get it right. There it is. So, yeah, we don't even have to do any math on these guys, but I was wanting to do the math. 'Cause I'm a math guy. Any questions? Are we cool with this? All right. Now I'm going to warn you, but we're done. We're done with the math. But the next set of things here on Thursday is like crazy. It's literally so crazy that I'm going to pull up the homework and we're going to do it like 4 times in a row. The whole homework 4 times in a row because it just is nuts. Okay. I want to do the workbook and then I'll do that homework with you. All right. There's my warning. Thank you guys.